So, I decompiled this thing called Xbox demos, and the response was quite small, if very pleasingly enthusiastic. Then I started applying what I learned to JSRF, and oh boy. Well, now that a JSRF decompilation is officially underway, I want to share a little of what we're learning about the game. Mostly just because I think it's really cool, that's why I started a decompilation, but also because some of this stuff will probably be useful for anyone that decides to help out, and we are pretty short on that right now. Anyways, we'll begin with the basics, the very foundations of the JSRF engine. So, let's get started. I feel like I'm saying this a lot lately, but JSRF is a C++ program, which shows up a lot in how the game's designed. That having been said, I'm not going to be walking through code today, but will really just show two very tiny functions. Here's the fully decompiled main function, more or less where the program begins. It creates an object that we'll call game, runs a little initialization code on it, and calls its main loop method. That method looks like this. All it boils down to is calling the frame method over and over unless there's some fatal error, in which case it freezes. There's too much going on in the frame method to show here, but the highlights are that we read input from the controllers, run all of our logic for the frame in what the game calls the exec phase, and then render the frame in what the game calls the draw phase. The input isn't particularly enlightening, other than using an in-house SmileBit library that we're still investigating, and the draw phase is a big enough beast of its own to merit an entire video, leaving aside that we haven't figured it all out yet, so we'll be focusing on the exec phase. For now, just know that the draw phase works pretty much the same way as exec, but with some added complications. To explain the exec phase though, I'll need to explain that game thing we saw earlier and another important class. To start off, what exactly is the game thing we saw in the main function? It's the sole member of the class that we'll also call the game class. This is what many people would call a God object, a globally accessible object that can do just about anything from anywhere in the program. Making a big class like this and making the whole program a method on it is, or at least was, a somewhat common pattern for hardcore object-oriented kinds of programmers, and this is code from the object-oriented heyday in a field that it's being particularly popular in. Anyhow, the game object keeps track of tons of big-picture game state, like whether to render a given frame, whether to draw extra profiling information on the screen, whether we've hit a fatal error and the game should just freeze, and a whole array of basically global variables, like chapter and mission numbers, which character each player is, whether we're currently playing the ending sequence, and so on. It also has public methods that allow for accessing and manipulating nearly everything in the game, like that array I just mentioned. To understand lots of its members and methods though, we'll need to introduce the other most important class, the GameObj class. Most classes you'll see in the game descend from GameObj. This means that a whole bunch of classes get some fields and methods from it. The most important methods are a set of virtual methods that child classes can override, where the different virtual methods correspond to the different phases of game.frame. Methods for the exec phase describe what logic to run for that object each frame, and rarely, what logic to run after every other object's logic has run. A draw method on a game object contains code for rendering that object on any given frame. As for where we keep these game objects, they're stored in a couple different configurations simultaneously for different purposes. Nearly all of them, for example, are given a numeric ID that's used as an index into an array inside the game class, and a pointer to the object is stored at that index. Since the game class has a method for reading from this array, this is what I'm referring to when I say that you can access just about anything through it. Game objects themselves, though, also hold pointers to each other that arrange them into a tree. When one game object is created by another, it's usually made a child of the one that created it, and each game object can hold pointers to its parent, its first child, and its next oldest and next youngest siblings. This tree structure allows, among other things, deleting all of an object's children recursively upon deleting it. What the exec phase does is walk the entire object tree depth first, calling the exec method of every object therein. The root of this tree, which we're tentatively calling the root exec object, has index 0, and is parent to some important objects like the SFX and audio stream managers, or a class we call a director, that handles a lot of the basic game flow. You'll see an example in a minute. There are a few other trees and linked lists used by the draw phase as well, not to mention every game object has a few flags that determine how it's used in the draw phase, but that's a story for another time. An added complication to all this is that JSRF has 5 basic modes it can be in on any given frame, and each phase actually has methods for each mode. That means that with 3 methods, exec, post-exec, and draw, for each of the 5 modes, there's a total of 15 virtual methods on the GameObj class. The modes are controlled by booleans on the game class, and while multiple modes can be set at once, only one actually has its methods run that frame, in accordance with some precedence rules. The 5 modes, from highest to lowest precedence, are covered pause, when a pause menu is covering the whole screen, event, when a cutscene, called an event internally, is playing, freeze cam, when the game world freezes for a certain camera angle, like picking up a graffiti soul, uncovered pause, when a pause menu covers only part of the screen, and a default mode, where none of the other 4 are set. Running different code for each object in different modes is how the game achieves things like not rendering the game world when only the pause menu is visible, because the covered pause draw method for most objects doesn't render anything, or making everything stop during freeze cam moments, because most objects don't do anything in their freeze cam exec methods, so the player character's position and animation won't get updated, for example. Almost everything in Jet Set Radio Future is implemented by constructing a big object tree where all the logic is contained within those objects' methods, called every frame, as the tree is walked in each phase. To wrap all this up, I want to show this machinery in action with a fairly simple example. The game starts up, the root object of the exec tree is created, and the director object is created as a child. What the director actually does is hold an index into a big list of functions, and all of its exec methods call the currently indexed function, potentially changing that index to something else. One such function, called very early on, creates a cache builder object, whose exec method does a little bit of work each time it's called to copy data from the game disk to the Xbox's hard drive to reduce load times. Another function called by the director loads the logos used in the opening credits, and the function after that creates what we'll call the opening object, which is responsible for showing the opening credits and deleting itself once it's done. Yet another director function after that activates a loading screen and updates the function index if the opening credits object has been destroyed. That leaves us with 4 loosely interacting game objects: the root exec object, the director, the cache builder, and the opening object. All 4 of these have their exec and draw methods called every frame. The root object's methods don't do anything. The director calls its indexed function. The cache builder copies some files and maybe records its progress. And the opening object goes through the different steps of the opening, showing logos on a timer and responding to input if need be. Let's look at just one of these objects real closely. I'll take the opening object, since only that one draws stuff to the screen. Its only defined methods are exec and draw in default mode, with no post-exec. The draw method is real simple. Each frame, we render the opening credits by painting the whole screen an appropriate color, black or white, setting the active texture to whatever logo or legal notice is supposed to be on screen right now, and then rendering it to the screen. The fade effect is actually produced by the exec phase, so that's all for the draw phase. The exec method is where all the action is. If we haven't already, we give the cache builder the go-ahead to start working each frame, since it does nothing by default. The cache builder only runs here, so that means JSRF uses its opening credits to make a cache to speed up load times. In fact, if you mash through this sequence, it won't finish, and loading screens may be a little longer as a result, at least the first time you load a given thing. In any case, we also record whether any controllers have pressed A or start. What happens next depends on a variable that counts up for each stage of the logo sequence, but we basically have 5 cycles of fading in during one stage, pausing during the next, and then spending another stage fading out. At the end of each stage, that variable is incremented, and the draw method can read it to determine which logo to show. Each stage is normally controlled by a variable that's incremented each frame to act as a timer, but A or start being pressed will skip to the next fadeout stage, unless the legal message is showing, at which point you can only skip after 7 seconds. Otherwise, it progresses automatically after 12. As for how the fade is performed, a function is called each frame that appears to slightly nudge the whole screen towards being fully visible or fully hidden. Anyhow, once the legal screen fades out, the next stage just destroys the opening object, which the director will notice the next time its exec method is called, and it'll show the loading screen and continue with the startup sequence. Outside of libraries like ADX or SmileBit's in-house Musashi library, pretty much all of JSRF is built on this system of objects getting 3 of their 15 methods called every frame. Once you understand this, you can move deeper into specific object types and what they particularly do in their own methods. I do hope this is interesting, or even helpful, for anyone that might contribute to the decompilation themselves. I expect I'll make some more videos like this one as we learn more about the game. There are just so many interesting details coming out of this, like some of the unusual features of the game's save format, and with only 1% of the executable delinked so far, there's surely no shortage of interesting stuff left to discover. I look forward to getting to share with everyone. Until then, see you later.